0.200 minus x divided by 0.100 plus 2x squared 0.300 plus x. And so one of the tricks that we learned was the simplifying assumption. You know, if the change is going to be small, which we expect the change to be small here, right? And so we can do the SA. SA is assume x is very small compared to the initial. Assume the change. Now the change is either going to be x or 2x. X or 2x is small compared to the initial. One way of thinking about this simplifying assumption is, say you had a swimming pool full of water, and if you remove a drop or add a drop of water or a couple of drops of water, did the volume change? No, the volume barely changed. And so this is the way we like to think about the simplifying assumption. You know, our initial's like the swimming pool, like this 0.100, and if we add 2 drops, it's no big deal. But how do we know it's only 2 drops? Because we don't know what x is, right? But we're just going to go ahead and assume that it's a couple of drops, and then later, when we do the calculation and we justify it, if the number comes out to, let's say, 500,000 gallons, then we know it's wrong. You know, the answer that we calculate using the simplifying assumption is a circular justification we were talking about earlier. But here, we're going to assume that it's small. And so this means that 2x is going to be much smaller than 0.100, and x should be much smaller than 0.200. Because these would be the biggest percent. I'm not going to say 2x is much smaller than 0.200, because if 2x is much smaller than 0.100, then it's got to be much smaller than 0.200. And so we'll just say 2x is much smaller than 0.100, and x, well, if 2x is smaller than 0.100, then x has got to be smaller than 0.200, right? And so, but we'll just go ahead and put it in there. I think I only need one. Which one would be the largest percent change? 2x compared to 0.100 or 2x compared to, x compared to 0.200? This one's not necessary, right? Because if 2x is much smaller than 0.100, then that means x has got to be much smaller than 0.100, right? And so I only need one of these. And that should cover all of them. If that covers all of them, then all these changes are very small, right? And so why don't you go ahead and solve this? Oops.